right, so we drew our diagonals just like we did yesterday. So from C to A and from D to B, and then we measured. So our diagonals to the midpoint, remember this is the midpoint, okay? From A to the midpoint is 2 inches. From C to the midpoint is 2 inches. From D to the midpoint is 1.5, and from B to the midpoint is 1.5. Your measurements might be a little different than mine because your side lengths might be different than mine, which is okay. As long as the opposite angles to the midpoint are the same, okay? So from our drawing here, we have these angles on the inside right here. These are all right angles, okay? They are all 90-degree angles. 90 times 4 makes that circle in there 360 degrees. So when you add up all of the interior angles, you should have 360 degrees. The line, when you draw your diagonals, that midpoint is also called a bisector. Okay, that's where these lines cross. That bisector is also the midpoint. And this bisector has all 90-degree angles. Not all bisectors do, but this one, because it has all 90-degree angles, it is called a perpendicular bisector. Okay, so you might want to write that note down. A perpendicular bisector is a midpoint with all 90-degree angles. So from this drawing, what attribute needs to be present to call a parallelogram a rhombus? All 4 sides have to be equal. And then the diagonals are perpendicular bisectors. Those are 2 important points when we talk about a rhombus. So when we talk about a rhombus, okay, 4 equal sides. That's one thing. And then the second thing, the diagonals are perpendicular bisectors. That means the interior angles are all 90 degrees. We're going to move on. This was problem number 1, rhombus. We're going to move on to a rectangle. Okay, number 2, rectangle. If I want to draw a parallelogram that is also a rectangle, what must I include in my drawing? Well, we know that rectangles are parallelograms. They have 2 sets of parallel sides. They need 2 sets of parallel sides. Rectangles have right angles and opposite sides that are parallel to and equal. So we're going to use our ruler to draw a rectangle. So I'm going to start here at 1 inch, and I'm going to go to 4 inches. Okay, what also is said about a rectangle? Let's do okay. So there's our rectangle. You can use a set square, which is a 90-degree angle, to draw that. Let's talk about our parallel lines that we see. Okay? We have parallel lines here, these two, and then the top and bottom lines are also parallel. Okay? You could cut out your rectangle and by folding it, confirm that the angles are all 90 degrees and the opposite sides are the same lengths. So this side and this side is the same, and this side is this side, and that side is the same length. But we know by using our protractor that all of these angles are 90 degrees. Okay, these are all right angles. Okay, now we're going to measure our diagonals and the segments of the diagonals. Oops. My ruler slipped a little bit. Okay, and when we measure our diagonals, we have 5 inches and 5 inches. So our diagonals are the same. Here is where they meet. And now we're going to measure our interior angles around this intersection point. They are not perpendicular bisectors. These angles are, let me make sure that I have a good, this is about 100, maybe 105. And this angle is maybe about 75. Okay, what you're going to notice is that these two angles are the same, and then these two angles are the same. Okay, so if we have 105 here and we have 75 here, that gives us this straight line right here of, a straight line is how many degrees? 180. Okay, and we have 105 here and 75 here, which give us again that other straight line of 180, and then 180 plus 180 is 360. Okay, so what do we notice here? So our rectangle, we know there are all right angles, the exterior angles. I'm going to put that word. All right exterior angles. Okay. Opposite interior angles are equal. So this one and this one, and then that one and that one. We also know that our diagonals diagonals are equal. So this diagonal and this diagonal are the same. So important things to notice here. Our diagonals are equal lengths. They are the same. The segments of our diagonals are equal. So from, if we did A, B, C, D, okay, from this segment to the midpoint, it's the same as this segment to the midpoint. This segment to the midpoint is the same as that segment to the midpoint. Angles between the parallel lines equal 180 degrees, right? So in between these parallel lines, this diagonal is 180, 180. Okay, even this, 180 and 180. And the diagonals, we talked about, they're equal. They bisect one another at that midpoint. Are these diagonals perpendicular bisectors? They are not, right? Because they don't form 90-degree angles. Good job. What properties must also be present for a parallelogram to also be a rectangle? The sides across from each other have to be the same or equal. And then we talked about how rectangles have all right exterior angles. All of these angles are right angles and 90 degrees. And the diagonals bisect each other. So those are the properties present. Okay, I'm going to write that down. Diagonals bisect each other. Right here at that midpoint. Okay, sides opposite or across from each other have to be the same length. Those are properties of a rectangle. So now you will work in your problem set. The only thing in your problem set that I want you to do is you were just doing number 1. That's the only thing you're going to do in your problem set. You're going to draw 2 rhombuses, one with no right angles, one with one right angle. And then you're going to draw a rectangle with not all sides equal, and then a rectangle with all sides equal. And a rectangle with all sides equal is what shape? A square. You got it, a square. So all you're going to do is number 1 today, and then you can do your exit ticket. Good luck.